Okay. Are we ready? Cannot wait. Okay, so rational functions, in this chapter, we're going to look at graphing them. When you guys did rational functions in Algebra 2, you did, you just simplified them and you multiplied them. Like that was the, before you simplify, factor first, that whole thing. Today, we're going to look at what we have to do to graph them. There's two things you have to know. Well, there's more than two, but two things that we're going to learn today. First thing we're going to learn is the vertical asymptote.
Asymptote?
I know, I have to concentrate. Yeah, that's how you spell it. Asymptote. It's just asymptote. And the horizontal asymptote. It's a hard word to spell. Okay, vertical goes up and down, right? Horizontal goes left and right. What an asymptote is, it's kind of like a magnet. If I have a graph that looks like this, you could just watch this. Let's say it goes like this, and then it goes like, you have this little imaginary line here, and then it goes like this. This is an example of a rational function. This dotted line here is what we would call a vertical asymptote, which basically means it's where the graph gets close to but never touches. So it's kind of like a magnet that it never actually gets stuck to. So it gets drawn to it, but it never touches it. It keeps going on forever in the directions wherever it's going to get right next to the horizontal asymptote or the vertical asymptote. In this case, the horizontal asymptote would be your x-axis here, which happens a lot. Same thing, the graph is getting really close to it, it's just not touching it. So an asymptote you never get to. Okay? I'm going to algebraically, we're not going to graph anything today, but I'm going to algebraically show you how to find these two things. So, when we have a rational function, it's going to look something like this. F of x equals 2x squared over x squared minus 1. The thing that makes a rational function is that it's a fraction. And since we can't get to the asymptote, it's where the graph is undefined. When we have a fraction, what makes the fraction undefined? Oh, that's not a good question.
Equals 0?
When what equals 0?
X. Y.
No.
Slope.
No. Just start saying every math term you know, over and over again. Not when something equals 0. There's something up here that can't be 0. Not, okay, don't think of a letter. Think of a
2.
area.
X squared.
The denominator. When the denominator is 0, it's undefined. Okay? So when you have your vertical asymptote, which I don't want to spell asymptote again, so I'm just going to put VA for vertical asymptote. You find your vertical asymptote when you have to set the denominator equal to 0. Because that's what tells you where it's undefined, where it's not going to be a graph, where it's going to be that dotted line instead of a regular line. So anytime you find vertical asymptote, we're just going to take the denominator of the function, and we're going to set it equal to 0 and solve. And if you notice the bell ringer we had, I picked the bell ringer because it looks a lot like our first example. When we go to solve this, I need to factor this down. Or you can just move the 1 over, but let's factor since we've been factoring. What does x squared minus 1 factor to?
I don't know. X minus 1.
X minus 1
X
and
plus 1.
x plus 1. It's a difference of two squares. And then when we set each one of those equal to 0, we get two answers. We get x equals positive 1, and here we get x equals negative 1. Everybody good with that? So my vertical asymptotes, I actually have two of them. I have x equals 1 and I have x equals negative 1. So if I was to graph this graph, I would have a dotted line going straight up and down at 1, and I'd have a dotted line going straight up and down at negative 1. It's where the graph is not going to get. It's going to get close to it, but it's never going to get there. So that's all you have to do to find vertical asymptote. And I'm going to do one more example of vertical, and then I'm going to go back and do horizontal for both of these. Because horizontal is different. Horizontal is not real mathy, it's just rules. 3 different rules you need to know. So let's say, I'm going to really switch it up on you here. Let's say I give you this one for your next one.
Wait, are we doing horizontal now?
No, it's still vertical. One more vertical, and then I'm going to give you the rules for horizontal. Then we'll go back and use these 2 for horizontal. Let's say I give you f of x equals 2x over 3x squared plus 1. I'm going to get tricky. Okay?
Ain't tricky.
It's tricky. To rock around is right. It's tricky.
White chick is playing my head.
Okay, so if I ask you to find the vertical asymptote, what are you setting equal to 0?
The denominator.
The denominator. So I've got 3x squared plus 1 is equal to 0. This is not a difference of 2 squares. There's nothing I can factor out, so I'm just going to move stuff around to get x squared by itself. So in this case, I'm going to subtract my 1 over. So I have 3x squared equals negative 1. Then I'm going to divide by 3. So I have x squared equals negative 1/3. Everybody with me? Then how do I undo a squared? Square root. Square root. So we're going to square root both sides. And what happens when you square root a negative?
Nice. Real nice.
I'm sorry, there's something behind this that makes it click out of there. I don't know what happens. Okay, back to my question. What happens when you square root a negative? Can you square root a negative? No, it becomes imaginary. That's when that I comes out. When you do the square root of like negative 25, it's 5i, because the square root of negative 1 is I. So anytime you have something like this, where you have to square root a negative, this means that there is no real vertical asymptotes. So there's times that you're going to find out that you don't actually get a vertical asymptote.
So,
Because this is an imaginary number. This is the square root of 1/3 I. It's not real.
Real.
So it's okay to not get a vertical asymptote. Okay? Now let's, huh?
Nova.
Nova, what?
It spells Nova.
Nova. No vertical asymptote. Okay, now I'm going to give you, grab your book. Okay, thank you. I'm going to give you 3 rules for horizontal asymptotes. So we're going to do, now. I'm going to tell you, this is going to look really mathy, but just write it down for reference. I'll use their letters. N, I can't see that. N is on top, M is on bottom. So if I give you something that looks like this, over something that looks like this. This is the mathy part, but it's really not mathy. It's just for reference. That's an M right here. M as in more math.
So it's A-N.
The top is N as in no vertical asymptote. And the bottom is M as in more math. I want to focus on these exponents here. The top one is the N, the bottom one is the M. So this is how we figure out our vertical asymptotes. By looking, we don't do any math, we just look at the problem that's given to us. So the first one they do is if your N is less than your M. So for example, if it looks like x to the third plus 1 over x to the fifth. So the top exponent is less than the bottom exponent. N is less than m. If that is the case, then your horizontal asymptote is y equals 0. So this is the first rule. You're going to want these written in your notes. So if the top exponent is smaller than the bottom exponent, then y equals 0 is the horizontal asymptote. Did you not know your schedule? I don't look at your mail. Okay? The next one is if n equals m. So let's say we have something that says x squared plus 1 over x squared. So my two exponents are exactly the same. If that's the case, actually I'm going to change this example. Let's say this is 3x squared plus 1. Just put a 3 out in front because it'll help what the horizontal asymptote is. If my exponents are equal, then y is going to be equal to a over b, or the numbers out in front of the x's. So in this case, what the example I just gave you, you would have 3 over what? What number's here? 1. So in this case, it would be 3 over 1, or just 3. So when they're equal, you take the number that's out front, and you make that a fraction, 3 over 1, or just 3. So y equals 3 is the horizontal asymptote for this. And then the last one is if n is greater than m, so the top is greater than the bottom. So I'll just make this x to the fifth plus 1 over x to the third. So now my top exponent is bigger than my bottom exponent. If that's the case, there is no horizontal asymptote. So you have 3 options. Y equals 0, y equals some number or some fraction, and no horizontal asymptote. And everything depends on, there's no math to be done. It's just you look at the exponents, the highest exponents on the top and the bottom, and you compare and you see which one it falls under. So let's go back to the 2 examples we did for vertical asymptotes, and let's find their horizontal asymptotes. So up here, is that our first one? No, that was our first one. Okay. Oh dear. Here we go. Okay, here was our first example. Y equals 2x squared over x squared minus 1. So they're the same, which is our number 2. So our second one, so we're going to use the numbers out front, which is a 2, and the number out front of this guy is a 1. So the horizontal asymptote for this is y equals 2, or y equals 2 over 1. So horizontal seems worse because we had to actually write out steps, but there's no math to be done. It's just seeing which one it falls under. And then the next one, I have f of x equals 2x over 3x squared plus 1. The top exponent is a 1. The bottom exponent is a 2. What happens when the top is less than the bottom? So n is less than m. You just y equals 0. When the top is less than the bottom, n is less than m, your horizontal asymptote is y equals 0. So, recap. Vertical asymptote, you set what equal to 0 and solve? The bottom, the denominator. Horizontal asymptote, and you're always going to get x equals something because that's straight up and down. The horizontal asymptote, you just have to look at the exponents and follow the 3 rules and write y equals whatever the number is, because that's your asymptote going this way.
Right.
Right. Got it?
Right.
So if I was to, going back up to this one, you don't have to write this one down, but I showed you these 2 dotted lines for the vertical asymptote. X is 1, x is negative 1. Here you said y was 2. So if I drew that one in, it would look like this.
Right.
So these two are my vertical asymptotes. This one is my horizontal asymptote. And the graph might look something like this. I don't know.
So we don't have to draw those things?
Not today. Today we're just going to find the vertical and horizontal asymptote. That's it.
That's easy.
Okay, so I'm going to give you, what I give you today, I want you to work on to the bell. But then tomorrow I do have a little bit of a lesson to add on, and then you have the rest of class time to work tomorrow. So don't take any of this home. You'll have time in class tomorrow to work.
Sounds good.
I'm going to change this. We're going to do 5 through 16. Page 337, 5 through 16.